All right, 1 and 2 students. Let me try another one here. Got a good question for number 26. Looks like it's the last one here in the homework, and it's a really a beats problem. What would happen if you had two waves that were different in frequency? Maybe just a little different might be the best way to draw it so you can kind of see. So what would you get if both of these were happening at the same time? I'm kind of hoping, maybe I drew them too far apart for you to kind of see this, but I'm hoping you can see this bottom one has a longer wavelength than this top one, or you might say this has a higher frequency than the bottom one. But at first they both go up, and so if you take the superpositioning of them, at first there would be constructive interference. But a little bit later, because they have different wavelengths, you're going to start to get a point, and it's illustrated here, where one wave is going down and the other wave is going up. So whereas you started with constructive interference, a little bit later you get destructive. And so the wave kind of tapers off in amplitude, and then you get zero. You get destructive interference. Now, as time goes on again, you get constructive interference again. And so it goes from 0 to getting bigger again. And you get constructive interference. And so if these are sound waves, what would you be hearing? I mean, if they were water waves, you would see them. I get that. But if they are sound waves, you would hear them. And what you would hear is you would hear a moment of loudness, constructive interference, and then a little later a moment of destructive interference. And so the sound would diminish. And then it would get loud again. And so you would hear kind of this wong, 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 wong. And what you're hearing is the difference in the frequency. How often do they go from being constructive to destructive? So we call this a beat frequency. It's kind of the rhythm, if you will. You might be more familiar with the word beats when you have a bunch of instruments playing along and the music is playing and it's got a pattern or a rhythm to it. And that's what we're saying. Now, this is only two sound waves, so it's not quite as entertaining as a whole band of musical instruments, but it is the fundamental physics of what would ultimately make music. It's the rhythm between these different notes that are played by the combination of the guitarist and the keyboard and the vocals. Anyways, and so all of those mixed together, and if done well, they sound pleasant, and you could make it sound unpleasant, either accidentally or on purpose. If you know a scary movie, they'll often put a pattern that has a disharmony to it, and it's supposed to add to that fear. It just doesn't sound right to your ears. Anyway, so we have harmony and disharmony depending on what you're trying to get accomplished. Anyways, the beat frequency then here is really what they're saying. So when I read this question, it says here, if you have a tuning fork of unknown frequency. So one of these is unknown. When you ring it alongside a tuning fork of known frequency. So I'll just say this is the known frequency. Oh, by the way, maybe I should put absolute value equals the beat. Because again, it just goes loud and soft, and you don't know really which one is bigger than the other. And then that's the challenge we're going to face here. It says you know one of them is 360, okay? And then you hear a beat of 2. So you're saying it gets loud and soft. It goes wong, 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 2 times every second. Okay. So what that would tell you then is that frequency number 2 must be either 2 above or 2 below the 360, because we hear it twice a second. We hear the beats. We just don't know if this one is above it or below it. But we definitely hear 2. So we know that it's either a 362 or a 358. So then it goes on to say, when you ring it alongside a 355. Okay, so we go with a 355. You hear a frequency of now, let me just check on this, because I don't know. Yeah, this should say you hear a beat of 3. Oh, good, and it does on the PDF. Okay, so the question was emailed to me by a student. I need to fix that for them. But on the PDF, it'll say you have a beat of 3. Okay, so what that would mean is then this unknown frequency number 2 is either 3 above or 3 below. So that means it's either 358 or 352. Now, obviously, the 358s line up. It's got to be, both of these at the same time. So this is trying to say it's either one of these or it's one of these, and the only thing that matches is it's the 358. So that's how we would conclude it's 358. All right. Hope that helped.